All right, let's begin. Year 11s. Quiet down. You guys can talk after class on Facebook. On your own phones, but don't do it in my class. I find it disrespectful. If you didn't want to be here, get out of my class. That's how it works. So if you're here, I'm trying to be here to teach. When I'm recording, I don't want to be recording me telling you off and everything. Yeah? And that goes for all my year levels, not just my senior levels there. Anyways, we just quickly revised exercise 2A there. Those are your two formulas, midpoint and distance formula. Hopefully you wrote the notes from last lesson already. Now let's recap on what you're meant to have learned for 2B, 2C, 2D. I will do 2E again because that summarizes everything together. Yeah, parallel and perpendicular lines. All right, so let's have a look. Let's go to 2B. What was 2B about? You can look at your notes. What was 2B about? Can I please have, yes, was it Hinda? Nikita.
Finding the gradient.
Finding the gradient. Now there's a lot of ways to find the gradient. And what I just did on this sheet is finding the gradient. You can find the gradient by looking at this equation. Let's say I give you 4 minus 3x. What is my gradient equal to? Can I please have, let's just go through. What's the role? I need to memorize your names as well. Let's go with... Oh, sorry, it's taking a while. Here we go. Let's go with first person, Hamish. 3 as my gradient? You're correct on the value, but incorrect in the sign. What is it correct? What's the correct answer, Yasmin? -3, yes. So remember, when you write y equals to mx plus c, that's the equation. M is the gradient. But remember, m is a value, meaning that it can be a negative gradient, positive gradient, zero gradient, or undefined gradient. In our case here, I've just switched the positioning to see if you can recognize what are you multiplying to x. The value multiplied to x right now is -3. This is together. That's a -3 times x. So your gradient is a negative gradient, not a positive 3. So it'll be a -3. That's my gradient. So 1. First part of 2b was to identify by looking at an equation. Second part. What if I then gave you, let's say, 3, 2, and 5, 6, and I said, I want you to find the gradient. How do you find the gradient of 2 points? Can I please have Matt? Substitute the, say it again? X and Y value. So which one's my X and which one's my Y value? Six is the Y. Yep, 6 is the Y. 3 for the X. So I substitute this X value equals 3 and I substitute Y equals 6. Is that correct? Into where? Into this equation over here? Incorrect. Because what you're actually doing here is you're saying this is a coordinate. That's a separate coordinate. It's a dot point on your Cartesian plane. So if you have a look, this means when x is 5, y is 6. So if you put that in your coordinate, you have 5, 6. It doesn't make sense to now say x equals 3, y equals 6. Because what you're saying there is you're saying you've got 3, 6. That's a different coordinate. That's saying now I've got x is 3, y 6. That's the coordinate you're talking about. Okay, so you can't mix the two coordinates you have. You have an x coordinate, y coordinate, they come as a pair. You have an x coordinate, y coordinate, they come as a pair. Yeah? But what we're trying to find is a gradient. Gradient, what is the definition of gradient again? Can I please, sorry, what was it? Lucy, what is a gradient again? Rise over run. Now this is key. If you don't know what a gradient is, write this down. Gradient is rise over run. Back in year 9, when we're doing rise over run, you're just simply looking at 2 points. Let's do it. 3, 2. So I'm just going back. 1, 2, 3, 3, 2. This is coordinates for 3, 2. We're looking for the second point. 5, 6. This is 4, 5, 6. Remember you used to label your axes in year 7 and 8? Yeah? And then you label your y-axis, that's 3, 4, 5, 6. Then 5, 6 will be this coordinate here. That's 5, 6. Gradient is how steep is that line. You're just asking, how much do you run across from this point to get to this point? How much do you go horizontally? And how much do you go vertically? That's as simple as it is. So horizontally, x coordinate, you started at 3, and this x coordinate is 5. So from 3 towards 5, how far is that? 2. Yeah, how do you know it was 2? What did you do? Yeah, minus 3 from 5. See, that was very logical. There's no memorization here. You're not meant to memorize. They're all logical. All you're saying here is you just said 5 take away 3, and you knew it was 2. So I know, I'm just going to do another color here so you can see what I'm doing. I'm just saying horizontally, from here to here is 2. But how did you know that? It was 5 horizontally. See 5? This is 5. Right there, that's 5. That's 3. It's just basic subtraction maths here. 5 take away 3 is 2. So now you know the run horizontal distance is 2. What's my vertical distance? You're now asking this point. You're saying from here to here, how far is that? Look at the coordinates. The coordinates tell you. They say horizontal is 3, 5. Now let's look at your vertical. 2, that's where you're at, 2. To the next y coordinate, 6. From 2 to 6, how far is that? 4. So to find the gradient of 2 points, you're doing 6 take away 2, 4 divided by 2 is 2. The gradient is rise over run 4 on 2. That's all you're doing. Vertical distance divided by horizontal distance. That was exercise 2b. Finding out how to read the equation. Second one was, how do you find it with 2 points? Okay, that's all you have to do for 2b. Understand the gradient. Now, in terms of gradients, I said before that you had a positive gradient, negative gradient, zero gradient, and undefined gradient. Now, for those who've forgotten or don't know forgotten their rules for a gradient, what I just did over here, the proper rule for it is m equals 2, y2 minus y1 over x2 minus x1. Okay, and I don't want you to memorize that because what you did with me is very logical. Why do you have to memorize these 2 minus 1, whatever it is? It doesn't make sense to me. All you're doing is just finding vertical distance, horizontal distance. That's all you're doing. You're just talking about the ratio. See, if it's a 3 to 3 ratio, then it's 1 to 1. Ratio means like if you put a cup of water, a cup of cordial, or if you're cooking rice, it's like 2 cups of water to 1 cup of rice. It's just that ratio. It's 2 to 1. It's the same thing with this one. Horizontal ratio with the vertical ratio. That's all you're doing. There's nothing more to it. It's just a gradient. It's a ratio. Yeah? So, this is what we needed for exercise 2b. Boys, exercise 2b, this is one of the formulas. Finding the gradient between 2 points. Then you had to know your types of gradients. Okay? From this formula, you can get a positive number, you can get a negative number, you can get a 0, or you can get no zeros, meaning undefined. Okay? Now, the only time you get an undefined is when positive makes sense. This is a positive graph. This is a negative gradient. What's zero gradient again? What does it look like? Horizontal line. Flat. 0 means like no incline. Okay, no incline. This is a flat ground. It's easy. We can run on this. But if I increase this incline to about 45 degrees and I say go run, that's tiring. Okay, running up, that's a positive gradient. When we're running up, that's positive. When we're running down, that's negative. Running down a gradient feels much easier. Negative gradient, positive gradient. 0 gradient, flat line. Yeah? But then what is impossible to do? Yeah, vertical. Hence undefined. It's impossible to run up a vertical line. I'm like me saying here, all right, I'm going to do your laps. I want 2 meters up the wall and down. And I want 3 laps of that. You know, it's just like, well, how do I run on that? Because the incline is just too high. It's undefined. Yeah? So, this is undefined. 0 gradient is when you have a horizontal line. Exercise 2b. Right? What was exercise 2c about then? If that was 2b, what was exercise 2c? Equations. So once you know your gradient, there has to be some use to it. And this equation is what you're drawing. See, the equation that you're drawing right now is all straight lines. So the equation of a straight line, are you writing these notes down? Because I'm expecting either you know all this already, or you've done your studies, or you're just being lazy. Which one of those straight lines? I've already done 2. Yeah, either being working on my class or you haven't come to class at all. Here we go. You've got y equals mx plus c. This is the equation of a straight line. Exercise 2c. You now know how to find m. Finding c isn't the hard. The hardest part was finding m. The hardest thing from year 11 to year 12, understanding what a gradient is what is hard. C is not. C is what you've done in 7s, 8s, anything in primary school. With your magic boxes. Yeah, if you remember back in primary school, you did magic box plus 3 equals 7. And you sat there and counted with your fingers. Those who were fast with their numbers, they're like 4. Right? You would have done 4. Then you got to year 7 and we said, all right, we're not going to use boxes anymore. We call them X. And we're like, all right, stop guessing now. Stop doing trial and error. We're going to teach you a method. We taught you inverse operations. We said, if you can add 3, so if I put 3 in, obviously I can take 3 out. Because this is my original number. I start off with a number. I added 3. So if you want to know what the original number is, minus 3. Go back. You put 3 in, take away 3. So it makes sense. If I took away 3 here, then I'm going to take away 3 from my original product. So if I took 3 here, I'll take away 3 there. That's the method you learned in year 7, which was confusing for a lot of kids. They're like, why do I have to do this? I know the answer. Now, when I teach the juniors, I'm like, no, it's not about knowing it. It's about learning how to do it. Because when I start giving you equations like this, where you have 2x plus, I don't know, let's say 7 on 3 equals 10, and I say, solve x. So I'm like, oh, wow, when will you ever use maths in real life? I never need to do this. Yeah? No, it's not about that. I was teaching you a technique. I was teaching you how to do things efficiently, and you either listen and try to work it, work with me and learn something, or discard it and just say, I'll never ever use this again. Okay? It's all logical right now. It's all about problem solving. That's the skill that you're doing. It's a skill you're taking from mathematics. It's critical analysis and application. Yeah? So here, if you can do 3 minus 3 cancels out and you get x equals 7, that is how you're going to find c. That's all you're doing. So let's have a look at an example that was like this. So exercise 2c, I'll give it to you. They'll say gradient is equal to 2, and they say line passes 3, 5. I'm just gonna make it up. Now they say if you have a line, it has a gradient of 2, so that's what you know, and it passes through 3, 5. What's the equation of the line? Okay, that's the question in exercise 2c. So if we have a look, equation of a line, we all know it has to look like this. They already gave us part of the information. They told you the gradient's 2. So you're like, all right, well, I already know m is 2 because they told me gradient is 2. So if I do that, you now have y equals 2x plus c. Your job is to find c. And that was what one of the quizzes were. Yeah, a range from hard to easy, from easy to hard. When I was testing, is have you been doing this homework? Because it tells me, do you know what a gradient is? Do you know how to find a gradient? Do you know how to find the equation? That's what I was doing. And the last part of that question was a parallel question. I didn't do a perpendicular. I was just testing, have you done 2A, 2B, 2C, 2D? That's all I'm doing. I haven't even asked you to sketch, actually. Okay? So all I'm doing here is just revising what you've learned year 7, 8, 9, 10. You can't tell me none of this you've never seen. You have seen them. Okay. So here we go. We've got 2, that's 2x. We want to find c. The only way to find c or to solve something, you need numbers. Right now you only got one number. The only way to help, 3, 5. Because the line says it crosses through this point. So that means when x is 3, y is 5. That's what you know. When x is 3, y is 5. So you're just putting pieces together. It's like a puzzle. I'm just giving you some information. Your job is to fill it out and find out c, find out m, find out x, find out y. That's what you did in year 9. Now we're just revising. Year 11, we're just revising. We assume that you know these. We can move on. Yeah? So here we go. We're going to do this problem, exercise 2c. As you can see, we say, since we know line crosses when x equals 3, y equals 5. That's what this means. When x is 3, y is 5, I put it in. I say, all right, well, apparently this line, this equation, whatever this equation is, I know gradient is 2, and when x is 3, y is 5. So you put it in. 5 equals to 2 times x, which is 3, plus c. Let's work that out. 2 times 3, which is 6. 5 equals 6 plus c. You can all work this out. And this is what I meant. Year 7, you came in primary school, you did this already. 6 plus something equals 5. Year 7 might have difficulty with that. Some of them will know it. But you don't need a lot of maths here. Yes, you can look at that and say, yeah, the answer is -1. I know that, but I want to see how you did it now. Because it goes all the way back to year 7. Did you learn your algebra properly? Did you learn inverse operations? Every technique you show me, I know how well your maths is. You don't show me your working solution, I don't know what you're thinking. I don't know if you guessed it. I don't know if you copied. I don't know if you're just sitting there and just went, oh, I have no idea what I'm doing, I just wrote a number. Okay, so here we go. From here, I've got C plus 6, and that's a positive 6 there. So I want to remove the 6 to get a C. What do you do? What's the opposite of adding 6? -6. So here we go, -6 on both sides. 6 minus 6 is 0. 0 plus C is C. And 5 minus 6 is -1. That's how we do it in year 7. We first taught you inverse operations. Now that we know, okay, we got M from the beginning. We got C, so therefore the equation y equals mx plus c has to be y equals 2x minus 1. That's exercise 2C. And there's a lot of ways to do that. You can do it with 2 points, which goes back to exercise 2B, finding out the gradient, but at the end of the day, this is all you're doing. Hardest one was to find M. Once you know M, you can find C. Any questions on those so far? All right? Okay, now 2D. Let's have a look at 2D. What was 2D about again? What are we doing in 2D? Sketching. Now sketching straight lines, back in year 9 there were 2 methods. In year 11, stick to one. Okay, there's no point doing the other one. There were 2 methods. You learnt in year 9, it was called gradient versus y-intercept method. And then from there, they tried to advance you and they said, you also learnt another technique, they called it X and y-intercept method. We don't use the first one anymore. So the first one is you counting. Start off with the y-intercept, look at the y-axis, you start at 1 point, and you read the gradient and you go across, rise and run, that's how you find the second point. And you sketch those 2 points. Because again, when you're drawing a straight line, how many points do you need to draw one straight line? 2. You don't know the minimum of 2. So here, if I gave you y equals to 2x minus 1, if I wanted to sketch that graph, gradient is 2. Rise over run means it's a ratio. So how do you write this as a ratio? What do you write 2? How do you rewrite 2? 2 over 1. This just basically means you rise up by 2 for every 1 across. That's like rice and water. For every 1 cup of water, you put 2 cups of rice. Or it's actually the other way around. Every 2 cups of rice, 1 cup of rice, you put 2 cups of water. Yeah? That's the same thing here. For every 1 across, you go up 2. So if you were to sketch this graph now, you would say this. You would say, y-intercept is -1, so I start at -1. 0, -1. And then you say, all right, well, according to the gradient, for every 1 across, you go up 2. So 1 across, you go up 2. So that's 1, 2. There you go. And that's what you did in year 9. You would have went, all right, so that's now 1, 1. And you put a ruler and you sketch that and you get your graph. That's tedious because you have to know what the gradient is. You have to count spaces and draw. Okay, we don't do that anymore. What we do is we use algebra only. X and Y axis intercepts. So for y equals to 2x minus 1, same graph. We already know the y-intercept. It was -1. So, all right, 0, -1. The only thing I'm missing, I just need 1 more point. X-axis intercept. So how do you find the x-axis intercept again? What do you do? Make y equal to 0. So you let y equal to 0. And therefore, in my case here, if this is my equation, y equals 2x minus 1, y is 0, 2 times x minus 1, and you're back to year 7 again. Everything goes back to the first step. Instead of doing trial and error, you learned how to do inverse operations. That's all it is. Year 7, 8, 9, 10 has been a precursor for methods. That's why methods are your standard. That's why a lot of students say, oh, it's all right, especially it's hard. It's only hard because you haven't been doing it for the last 5 years. You've been doing 7, 8, 9, 10. You've been doing that, including this year. You've been doing it for 5 years. That's why methods in year 12 feels easy. It's not. Imagine if you only had the first time you rocked up after grade 6 and I went, yeah, these are methods. Year 12 methods. You're like, oh my God, there's a lot. It'll be so hard. Yeah, if I give you only 2 years to learn quadratics and linear equations and cubics, you're like, this is the hardest subject ever. No, because you had 5 years to learn everything that you needed for methods. Of course it's easy. With Spesh, there are a lot of topics you haven't learned. Like complex numbers, surds, and vectors. You didn't learn all that. That's why it's hard. But the subject itself is not hard. It's just you had 5 years to train. So now if I asked you about negative numbers, you're like, oh, that's easy. But remember the first time you learned negative numbers in year 7, it was like, why? 2 negatives equals positive. It was hard. But it all takes time. Yeah, so year 11, it will feel hard. Year 12 will be easy. You learn it all in year 11. Year 12 will be easier. Yeah? All right, here we go. So X-intercept, solve, +1 on both sides. We get 1 equals 2x. Divide both sides by 2. And voila. We got half 0. Same thing. Okay, so that's exercise 2D. X-intercept, Y-intercept, you're simply using it to sketch. No matter how crazy the equation looks, even if I gave you this one, even if I said 3x plus 2y equals 7, and if I told you to sketch that, you don't have to rearrange that. You don't have to rearrange it to make it y equals mx plus c. You don't have to. If you were to sketch it, you only need 2 points. X-intercept, Y-intercept. That's all you need. 2 points to sketch a straight line. And that's what 2D was about. So if you have a look at this graph here, simply the same thing. X-intercept, you let y equal to 0. Whereas Y-intercept, you let x equal to 0. So if we were to do that, this one here, you have 3x plus 2. Instead of y, you have 0 equals 7. Solve it. 2 times 0 is 0. 3 times x, remove 3 by dividing both sides by 3. Answer 7 on 3. Yeah? I'll write it down, by the way. I'll write it down. This becomes 3x plus 0 equals 7. 3x equals 7. Divide both sides by 3. 7 on 3. Yeah, so I'm keeping you. See how my layout is? All my equal signs vertical, and I'm showing you my method. So even if you looked at it, if you didn't understand what I was saying just now, or I was speaking too fast, you understand what I'm doing. That's how I want to see you lay it out too. When you're doing your stacks and everything, it has to make sense. It wouldn't make sense if you just did that and wrote that answer. I wouldn't be able to read you. I'll have no idea what you just did. Do it that way, at least I understand what you're doing. Okay? Then your Y-intercept. See, Y-intercept, we know the x has to be 0. Same thing. 3x plus 2y equals 7. X has to be 0, so 3 times 0 plus 2y. 0 plus 2y. 2y equals 7. And same thing, double y gives you 7. So if you're doubling, then halve it to remove it. So divide both sides by 2. 7 on 2. Now you've got your 2 coordinates you can sketch. X-intercept, Y-intercept. So if you were to sketch this, X-intercept was at 7 on 3, which is about 2 1/3. So that's like, what, 2 1/3 there? That's 7 on 3. And 7 on 2 is what, 3.5, yeah? So 3.5, let's say there. 3.5. Oops, 0 and 3.5. There you go. Straight line. You don't need to rearrange the sketch. That was exercise 2D. How do we feel? Yeah, now if you're still feeling like this is a lot, the videos. Each video is like, some of them was like 45 minutes to an hour. I spent an hour for you, and if you're not doing that for yourself, I can't do anything else. I'm doing quizzes, I'm doing videos. I knew I was going to be away 3 days. I told you in advance. I made the videos for you. I've done the quizzes. I'm going to check your work. And if you're still not keeping up, I really don't know what else I can do. I'm doing my best for you. So you do your best for you too. Right? That's what I want. If you didn't want to be here, you want you to roll in it. Yeah, because I wasn't here for that too. So I made a video for it. I made a video on 2B. I'm talking about that angle. And if you want, I can make another video with examples. I'll do some more examples. I'll make it as an example for 2 videos. No, not at all. I'm doing that this weekend for my Year 12. So the Year 12s are following and they're on schedule. It's just you guys are seeming a bit off track right now. So I'm going to make sure you're all on track. The videos are up there. Yeah? What are we supposed to have done? I came in expecting you had sort of understood all this, and I was going to do 2E, but at this point, most of you are sort of sitting somewhere in between all this. So if we have time, we don't have time. I was going to do 2E, parallels and company, so that means quite a bit behind now. Next session on a Monday, I will be doing 2E, and if I can squeeze in 2F as well, I will do 2F as well. So solving equations, and 2E was parallel and perpendicular. Those are the two I'm going to squeeze in on Monday. Okay? But please don't fall behind. Year 11 is actually the hardest year for you to understand your concepts. Year 12 is not. Everything I'm teaching on Year 12 now requires you to know all this. It means that Year 11 is the hardest year. Everything you've done from 7 to 10, you're squeezing it in 1 year. You just got to show me you know it. And that's the hardest part. If you haven't been doing maths well in 7 to 10, it will show. I will know how well you've been from junior level, from 7 to 10. I will know from this year just by looking at your workings. Question 9. Okay, I'll do that with you. But the bell's just about to go, but I'll do it with you, yeah? Alright, come up here.